Hello everyone. A question that often comes up is how to design a gear in a CAD system. In particular, the profile of the tooth of a gear, otherwise known as the involute, is rather complicated to generate using conventional CAD techniques. In this video, I plan to share a simple method for designing a gear using a technique known as the Wellman's involute. For this, you will need to access a free software program called Gear Designer that you can download from our website at www.opsollc.com, and any 3D CAD software program to convert the results thus obtained into mathematical data. In this case, I will be using ANSYS Space Claim for my CAD interface. Let's take a look at a real life problem to design a gear. In this case, we are tasked with a gear set, a spur gear set with the following specifications. There is a pitch of 4 per inch, a pressure angle. Gear 1 is to have 12 teeth, gear 2 16 teeth, and then there are some other specifications such as the bore diameter, the keyway, and the width. The parameters that you see in the black font here are those that will be put in as inputs into the Gear Designer software. The parameters in the red font here are those that will only be input into the CAD software. So let us go into the Gear Designer software. The main screen of the Gear Designer software consists of a left-hand side area, which is where you input the gear parameters, and then the mid and right hand side area where the software outputs the results. So going in here, let us input the pitch of 4, pressure angle of 14.5, gear 1 having 12 teeth, and gear 2 having 16 teeth. We hit solve, and there we have our gear profiles. Now we have to take this information somehow and convert it into CAD data, into math data. And for doing so, in this case, since we have a limited amount of time, we will only go ahead and design one gear. In this case, I'll go and design gear number 2, the one with 16 teeth. And the process for designing gear number 1 is identical, so we don't need to repeat the same process again. Having said that, let me go to my ANSYS Space Claim software, and what I will first do is to put this in a plan view. The first thing we do here is create 4 circles which are concentric, meaning have their centers at the same point with the following diameters: the outer diameter, the pitch diameter, the base diameter, and the root diameter. Now I'm going to go pick on the circle tool, go to my origin, and put my first diameter as 4.5. The second diameter is going to be at 4. The third diameter is going to be at 3.8726. And the fourth diameter is going to be at 3.4215. Then I'm going to construct a vertical line from the center of the circle that cuts through all the 4 circles as such. Having done that, I will identify my pitch diameter by coloring the circle red, and I'll identify my base diameter by coloring that circle blue, just for developing a sense of clarity and avoiding confusion. So there we have our pitch diameter is red, our base diameter is blue. Now I'm going to construct 3 circles with the following diameters: the large involute diameter, the small involute diameter, and the quarter tooth thickness as a diameter. Each of the circles, again, these 3 will be concentric circles. Each of the circles will have the center point at the intersection of this vertical line with the pitch circle. So going in there, let me go ahead and construct my first circle at 1.73, my second circle at 0.58, and my third circle at 0.3921. Having done that, I will now create some points. The first point is created at the outermost circle here, where the outermost circle here intersects with the base diameter. So this point. Next is the second circle from the outermost end, where that intersects with the base circle, and that's this point. And the third is going to be the innermost circle that we just created, the intersection of that circle with the pitch circle, which is the red circle, and that's going to be this point. Having done that, now I can go ahead and come back and delete these circles because we will not be needing them anymore. Now, we will go in and use the same three diameters to construct three different arcs. So the first arc that we will construct is going to be from this point to the intersection to the pitch diameter and going across the outermost diameter. The second point is going to be from the second point, the same intersection, the pitch diameter, and then going past this base diameter. And the third line that we will be creating is going to be a line that's going to tangent to this arc and which will be vertical. So there. Having done that, I'm going to create one more fillet, which is the fillet radius here of 0.0434. So I'll create that between this vertical line and the base and the root circle, which is this one here, and I'm going to give it a radius of 0.0434, and there we have it. Now I'm going to go and trim off the unnecessary areas. So I'm going to trim this off. I'm going to zoom in there and trim off that portion of the arc. And then I'm going to create another construction line, this time from this point here, which is the intersection of the innermost circle that we had created with the pitch diameter circle. And I'm going to create that to the center of these arcs, these lines. So I'm sorry, center of these circles. So this is my center line. Now I'm going to go ahead and reflect this profile about the center line. So I'll go and mirror about this line. We will construct our complete profile as such. Then we will trim off the unnecessary areas of this profile. And also we can delete our other diameters, which we don't need anymore, and our other lines and our other points. So what we are left with is the generation of one tooth. And very easily we can take this tooth and we can create a polar array of this tooth. In Space Claim, this is done by the move command. So we select this tooth and we use the move command, bring this center point, and then create patterns. And all we have to do is go ahead and create a pattern here with a count of 16. And there we have our tooth geometry generated for the entire gear. I'm going to trim off the unwanted areas. And what we should be left with is the outer profile of the entire gear. However, there is a little bit more work remaining to be done, which would be to construct the inner bore and keyway. That's fairly straightforward. We go ahead and create our inner bore, which is 2 inches in diameter, and we create our keyway, which is, again, I'll go to snap to grid and create my keyway, which is going to be 0.25 inches across and 0.125 inches high. And I'm going to be truncating the portions that we don't need anymore. We have that, all those portions cut off here. We can also delete this vertical line as we won't need that anymore. So there is the full profile ID and OD of the gear that we have generated. All we have to do now is to extrude that. In Space Claim, we use the pull command, and using the pull command, I can just grab onto this surface and pull it to 0.5 inches. Lastly, I can go ahead and delete what I don't need anymore, and I should be left with the entire geometry of the gear. So there you see, it was a fairly easy task once we used Gear Designer to go from there and then generate our profile in the space claim software. Hopefully, this was a helpful tutorial and will help you generate your own profiles in the future. Thank you very much.